This is what the Cisco routing and switching world is all about. BGP tuning attributes. I was getting more and more excited as I was preparing the slides for this video, and then I got to the part of where I was going to put together a live demonstration of how to actually modify the BGP attributes and tune them, and I was just thinking, this stuff is awesome. I love it. Many of you may know that I specialize in Cisco voice over IP, and it's kind of, I don't want to say it this way because it sounds bad, but it's kind of a necessary evil in the sense that overall, voice over IP is neat. It's kind of fun, but in no way does it compare in my mind to routing and switching. That's what I have my CCIE certification in, and that is where my true passions lie. When you see this stuff, I will say this. If this video does not get you excited about how cool it is to be able to work with BGP and use BGP, and I guess the routing and switching world in general, then check out voice over IP because this is as cool as it gets in my opinion. We're going to look at what the BGP attributes really are. You know, what are these things that we've been calling attributes? We'll look at how BGP uses attributes to find the best path around the network. We're really going to see what the metric of BGP is. And then we'll look at the basics of modifying BGP attributes, which by far is going to be the largest demonstration I've done so far. It's going to be 7 routers that are combined into this large BGP network. And you might be thinking, Jeremy, did you need 7 routers to do that? Absolutely not. But the bigger it is, the better it is, and the more real world it is. So I went through the trouble of creating a 7 router network and tying it together using BGP. It's going to be cool. Let's get going. So we have to start off with the question of what are BGP attributes? I mean, before we can get into the tuning and modification of them, we've got to see what they really do. And I would say that the best way to describe BGP attributes are just little tags that you put on incoming or outgoing BGP routes that make its metric. See, when we think of metrics and we think about routing protocols, we usually think about things like RIP, where we have the metric of hop count. Very simple, very easy to understand. You look at OSPF, which has a metric of cost, which is just 100 divided by the bandwidth, and that's, pretty simple, pretty easy to understand. I guess the most complex metric we've ever seen is EIGRP, which is the bandwidth and delay, but even that pales in comparison to how vast and tunable the metric of BGP is. We're going to see a whole bunch of attributes that all go into a list. Like when we're trying to find the best way to get around to these BGP routes, there's a giant list that BGP uses. Let's check this, let's check that, let's check this, and it'll go through one by one until it finds something that looks better on a route. Now, you see all these boxes on the screen around these attributes because these are the official standards-based categories of attributes. You'll see some attributes that we talk about that are considered well-known, meaning every vendor supports them that claims to support BGP in a standards-based way. There are some other attributes that are going to be optional, meaning these are some tags you can put on the route to tag it in some way, but every vendor may not support it. It's not required that they support it, so they may not put it in their implementation and they're just fine. Now, likewise, you're going to see some attributes that are mandatory, meaning they must be in the update. Every BGP route has these attributes. And let me give you an example of one of these attributes because I don't want to just leave it this vague, mysterious thing. An attribute is as simple as a next hop address. That is actually a well-known mandatory attribute, which means that everybody has to support a route coming to them that has a next hop address, and likewise, every vendor must have that in every single update that they send for the routes. It's mandatory. I mean, you can't have a route without a next hop address, or how do people get there? Sheesh. So mandatory attributes have to be there. Discretionary attributes may or may not be there. It's just one of those options that you can tag on there. So the final categories you can see are transitive and non-transitive. The attributes that are transitive will travel from router to router, or more accurately, from autonomous system to autonomous system. So maybe I put my tags on the route, but a non-transitive attribute would be a tag that stays within my organization, meaning maybe I'm an ISP and I tag certain routes this way so that I can deal with them later in a certain way, but I don't want other people to see those tags. Whereas the transitive attributes that we have in there will follow the route everywhere. For example, a transitive attribute might be something like an autonomous system path. That happens to be a well-known mandatory transitive attribute where every autonomous system that you go through puts its little stamp on it, like it's been here. It's kind of like a passport. We'll see. I don't want to get too deep into the details of attributes, but just to show you, to demonstrate the different categories that these things can be. Overall, as I've met a lot of people in the networking industry, I've found two major types of people. There are people that do networking and kind of do it for a living. Like you talk to them about networking and they know what they're doing. They do a great job at it. But at the end of the day, they're kind of like, okay, that's done. I'm going home and I'm, reading a book about grass or bird watching or something like that. And then there's another category of network people that like live this stuff, meaning they go to work and it's almost like work is an adventure of, let me try this, and they blow up their company's network and they're like, oops, they just switch it back. It's just they do stuff because that's what they like to do. They want to find out what happens. And when they get home, there's no books about grass or bird watching. There's just technology stuff. They read technology stuff, and when they're not doing networking, they're usually doing something with technology. Now, regardless of what type of person you are, you have to be essentially in a closet of technology. If you haven't heard of that little picture that I have on the screen right there, that is actually the game that I think overtook the world 2 or 3 years ago now, called World of Warcraft. It's where you essentially make this little character. You might have heard of a kind of competing game called EverQuest. They're both similar concepts. You create this little character and you just live in this virtual world where you live online and you meet people online. I've even heard of people getting married in these games. It's very strange. But in this World of Warcraft game, you have this character where you kind of have all these attributes. I know that I'm not a World of Warcrafter. I really don't have time for the addiction. I'm more of a first-person shooter, pick it up, shoot somebody, put the game down. But my brother is really into World of Warcraft, and this is how serious it gets. He created this character where these attributes became so powerful that he was ready to be done with it, just kind of retire from World of Warcraft first season, and he was like, "Hey, Jer, can you sell my character on eBay? Because I have an eBay account." And he goes, I hear these things go for a lot. Well, the minute I put it on eBay, I was getting emails and people were offering me $1,100 for this character. I kid you not, $1,100 for this little man that does not exist in real life that has all these items that he's collected and special abilities. Now I'm digressing on this thing just because it's very interesting to me that people would pay $1,100 for something that doesn't exist. But more interesting as it relates to BGP is this little character is so valuable because it has all these great attributes. I mean, when you're looking at the characters on World of Warcraft, there's no doubt, you've got the strength, the dexterity, the speed of movement, the weapons that they can hold, and all these. And based on all these attributes, you can kind of get a feel of like, hey, that's a pretty good character. I mean, and when you would go against this character, this guy would definitely win because he has better attributes. Take that analogy, which went way too long, and apply it to BGP, okay? BGP has all of these routes coming in, and I'm just giving you some of the attributes, the big ones, the ones you will see all the time, right on the screen right here, in all this red text here. Those are all example attributes. To tie the two together, you might get a route coming in where it says, oh, the strength of this route is 40 out of 100. The dexterity though is an 80 out of 100. Down the line, all of these attributes, but then you get the same route coming in from somewhere else. I mean, think about it. The internet. The internet. A network of networks. Would you consider the internet a redundant network? Oh yeah. I don't know if you've ever seen the picture of the connections. There's actually a picture they have on the internet. I don't have it on me, but I usually carry things like that around. But it shows all of the WAN links on the internet, and it's just a big blob. Is the point? You can't make out the WAN links because it's so interconnected that it's just a big blob. All the lines end up blurring together. So the point is that you have all kinds of redundancy on the internet, meaning that you have all kinds of ways to reach any given network. You might open your web browser in the morning and go to google.com, and sure enough, you do a trace route to it and find out you're taking one path. Do it again in a couple hours, and you take a totally different path because these paths on the internet are always changing. So, my point. Somewhere in here, there will be a point. Your router is going to get the same route from many different routers when you're running BGP. You might get, just to give you an example, the 200.1.1.0 network. You might get that route 50 times. It depends if you're an ISP because you've got all kinds of redundant connections coming out of you. And now your router has to pick one. Out of all the 50 people saying, I can get you to the 200.1.1.0 network, your router is going to have to say, well, I can only have one best one, so let's look at the list. Autonomous system path. That's one of the well-known attributes. The autonomous system path is how many autonomous systems do I have to go through to reach that 200.1.1.0 network. The next hop address, you can see this is a well-known mandatory attributes. That's what I'm putting in these parentheses. Everybody has to have it. One of the questions a router might have is, did this come in with a reachable next hop address? Because you know what? If it's not reachable, it doesn't matter how good all your attributes are, how great your character is. I can't get there, so you're immediately disqualified. The origin of the route. Did this come from, somewhere inside of your network? Did it come from maybe another external routing protocol? Or do we not even know where this route came from? Is the origin incomplete? Those three, by the way, are the well-known mandatory attributes, period. Every route that comes in must have the autonomous system path, every autonomous system it's traveled through, the next hop address, and the origin of where the route originally came from. All the rest of these may or may not be on there. Now, I am showing you a list of about 7 attributes here, but do know that there are more, and that's what the BGP video series is all about. There's, a whole series dedicated to going through every single one of these attributes. So you can imagine we're not going to go through every single one, but I do want to hit the major ones. Local preference, how preferred is that route within your autonomous system? So the point is that I don't want to go through every single attribute talking about them here. The point is that every single route that comes in has its own giant stat list, just like this character. I was trying to think of what that character was, but I don't know. This character in World of Warcraft has all of these stats that are listed right there. And all of these networks that are coming in will have the stats listed. You need to know, how's the router figure out which stat is best? So are you ready for this? This is BGP's metric. Whoo, Nelly, look at that. 14 different decisions total, 0 through 13, that BGP goes through to try and find the best way around the network. It makes the EIGRP route, where they can have 5 different things included as the metric, just seem like child's play. Look at this. And by the way, if you are studying for the bsci certification exam, you aren't going to have to fill your mind with this entire chart, but I would recommend knowing 0 through 4 pretty well. If you're studying for the BGP exam, I'd recommend knowing the chart. So here's the scoop. BGP receives these routes. Let me just grab my pen here and draw a little bit. You might have this router that's an ISP router that, has connections to all kinds of other routers. So it's going to be receiving the same route, the same internet route from all sorts of other different destinations. Now, if you're receiving the same route from 4 different neighbors, the path that this goes through, or the process that BGP goes through to try and find the best way to get there, is number one, immediately ignore routes that have an inaccessible next hop address. It actually happens more often than you may think with that next hop address. I'll show you that when we get into the live demonstration. So let's say that, all these routers are sending that 200.1.1.0 network, and you're getting the same route. The first thing it's going to look at is, does any one of these neighbors, are they advertising that network with an inaccessible next hop address? Now you might be thinking, again, why would it be inaccessible? If I can reach a neighbor, well, then it should be accessible, right? Well, remember, the next hop doesn't always change with BGP. Again, we'll see that when we get into the demonstration. The next one that it goes as it tries to break the ties, it says, okay, I will now prefer the path with the highest weight. Now, the weight we haven't talked about yet. That was one of the attributes that wasn't listed on that list because it's a Cisco proprietary attribute. That's one of the only ones. It is the only one in this entire list that belongs to Cisco alone. The reason that it's Cisco proprietary, and it's not really, that big of a deal, and you don't hear everybody complaining, oh, Cisco's got their own set of attributes, is because the weight is a unique attribute that stays local to this router. Meaning, I can go on this router, get into the configuration mode, and if this is a Cisco router, I can type in, I want routes that come in from router 1 to have a higher weight than the routes that come in from router 2. So immediately, this router, because I configured it locally with the weight command, will prefer all routes from router 1 over router 2. And there's different ways of tweaking that and so on. We'll get into that when we get to the live demonstration. But that's the very first thing that it's going to prefer, of course, because it's the Cisco proprietary one. That overrules everything. Now, I want you to look at this list like you would an access list. It's ordered. And when you get the first match, that's it, game over. So in a way, you've got all of these attributes, but it works from the top down and says, okay, well, if this one breaks the tie, then I don't need to look any further. For example, if router 1 is sending routes in and they're being marked with a higher weight than router 2, then I'm going to choose the ones from router 1 over router 2 because that's just the way of things. I'm not going to look any further. Now, what if router 1 and router 2 are sending that route in and they both have accessible next hop addresses and the weight is tied? Well, at that point, we drop down to the next one. Prefer the path with the highest local preference. Now, again, we haven't gotten into these attributes specifically. We will. I'm done saying that. We will when we demonstrate this. But the local preference is something that I configure on this router that is advertised to other routers. So I can, again, say, I prefer the ones from router 2, maybe with a higher local preference than router 1. And at that point, if everything's tied, it reaches this second one right here and says, well, then I prefer the routes from router 2. All of these things require that you, as an administrator, set something, meaning that they will be all tied by default unless you change something. So if you haven't changed anything, it's just going to keep working down this list and reach this third one. Prefer the path that was locally originated via a network command. Now, this is kind of funny because it rarely happens. It's going to go down the list and say, okay, I've got this one from router 1, I've got this one from router 2, and then it looks and goes, oh, well, I'm advertising this. Good grief. I'm directly connected to the 200.1.1.0 network because somebody used the network command to put it in there. Okay, at that point, I'm going to prefer that. But you can imagine that rarely happens because how often are you connected, to the network that is in question, I guess you could say, when there's millions of routes floating around the internet. So we come down to the fourth one, and that's where I'm going to stop for now. Prefer the path with the shortest AS path. This will usually break the tie. Meaning if I am an internet service provider, and I'm receiving routes from all these different upstream internet service providers, well, each of these people, all of these systems, I should say, have different connections through the internet. They all go through different autonomous systems and, reach, other autonomous systems. And, they may overlap at some point. And maybe the 200.1.1.0 originated from this autonomous system up here with my exclamation point. Well, at that point, some of them might be one hop away from that autonomous system. Others might be, 2 hops away, whereas others are 3 or 4 hops away from that autonomous system. So by the time it gets here, you're going to get a network, 200.1.1.0, from 4 different people. One of them will say, well, I can get there going through one autonomous system here and one here. And I'm there. This guy says, well, I can get there, and I'm just plugged right into that autonomous system. This one says, I go through one and reach that. So you're getting, I kind of defeated my example because my clouds aren't as big as the internet. But the point is that you'll usually break the tie in that fourth step right there because the connections of the internet are so vast that it's very likely the AS path will break it. That's why I recommend when you are thinking about the BSCI exam, usually I would know up to the number 4 right there because that's usually what breaks the tie. So Cisco knows that, you usually will not need to go beyond that. But if you do, you can see that it keeps going down this list until it can find some different, eBGP beats iBGP, lower IGP metrics to the next BGP hops. This just keeps going down the list until it finally reaches number 13. And you can see number 13 says, prefer the path that comes from the lowest neighbor address. That is a completely random choice by the time you get to that point, because you can know that number 13 will break the tie. You're not going to get the same route twice from the same neighbor. So it's going to look at all these neighbors and say, guys, who has the lowest IP address? Router 2 says, that's me, and sure enough, router 2 becomes the final destination. So number 13 will break any tie that we end up having. Let me put some practicality to all those attributes. This is going to be our live demonstration topology that we use for tuning the BGP attributes. Now you can see that I've got a pretty large network. We're focused in on this blue autonomous system over here, 5500. That's our world. That's our network. We have connections, dual connections to the same service provider in autonomous system 777, who has redundant routers, and each router has a different path around the internet. One goes through autonomous system 911, one goes to autonomous system 711. Now the point of this whole story is going to be focused on a network that is originating from router 7. It's this LAN connection, 200. I believe I put 50.2.0/24 is the IP address of that network. Now that is being propagated via BGP through autonomous system 911 and autonomous system 777. We're going into autonomous system 5500 directly that way. This one comes through 777 and then reaches it directly. So both router 2 and router 3 have 2 different paths that help them reach that network. Both of those will end up sending it to router 1. So let's bring up router 1. That's the one I want to focus on here. And I'm just going to do a show IP BGP summary to verify our neighbor connections. Yep, sure enough, I can see that I have 2 connections, one to 12.2 and 13.2. That's essentially router 2 and router 3, my 2 exit points from my autonomous system right here. And then each one of them have sent me one prefix. So I have, the single network being advertised. Let's look at it. I'll type in the command show IP BGP. Now, let me interpret this table for you. We've got the BGP table, which you've seen before, but I want to point out here that we have network 200.50.2.0. That's the network that's been advertised from that system. Now, this is not a list of 2 networks, but rather 2 paths to the same network. You can see my one network is right here, and I've got one path that has this next hop and one path that has this next hop. Now, we're used to seeing routing tables, so it's very easy to assume, oh, we must be load balancing to reach that network. But that's not necessarily true. The BGP table has all of the best paths and the second and third and fourth best paths. Only the best will end up in the routing table. And in this case, you see which one's best? That one. You can see it with that right angle bracket. It's saying that one is the best. So if I were to do a show IP route, there it is. BGP 200.50.2.0 via 10.1.36.2, which is this next hop right there. So you can see that it does choose one best route out of the table. Let me just clear all that off and focus in on just the BGP table. So choose one best route. Why did it choose that? Well, right over here, you can see our list of BGP attributes, the next top attribute. Now, it says, number one solution when it's trying to figure out the best way to get to a network is it ignores the routes with inaccessible next hop. Now, I can guarantee you that, at least right now, router 1 can reach both of those next hop addresses. So, we move down to number 2. Prefer the path with the highest weight. Let's jump back to our topology, and let's see, right here, there's our weight. We can see that the weight is set to 0, which is the default. So immediately we're tied. Next in the list, the one with the highest local preference. Come back over here. There's our local preference attribute. And the default on every Cisco router for local preference is a local preference of 100. So again, we're tied. Both of those are equal. We come back and we see prefer the path that was locally originated, and both of these have next hop addresses, so neither one came from this local router. It came from router 1, so that's ruled out right there. So we come down to number 4, prefer the path with the shortest AS path, and now we see that is why this became the best path, is because it goes through 10.1.36.2. Now, by the way, 36 is router 3. Let me bring my topology back up if I can find it here. Right here, router 1 is preferring router 3 because router 3 goes 1 hop, 2. I'm there. Goes from 777 to 711. That's the only 2 paths it ends up taking to reach that. So you can see that BGP by default is boiled down a glorified RIP, where instead of using hop counts where hops are routers, it uses hop counts where hops are autonomous systems. So that means if you're really serious about running BGP, you've got to get in there and tune it. You've got to get in there and set these local preference and weight attributes. Overrule that default system where the shortest AS path wins. I mean, what if you had this? What if your system had a T3 connection up here to router 4 and a T1 to router 6? And you know, because you've talked to your ISP, that router 4 is by far the fastest router in their organization. It's got T3s the whole way through all the other systems that goes to Autonomous System 711. Well, in that case, we'd want to prefer that path, but BGP won't let us because, well, the shortest AS path wins. That's the decision criteria. So I'm looking at the clock. I took a moment because I was like, where am I? I've got to find my time here. I don't have enough time to do the full demonstration, at least and keep this a short video rather than some sort of epic novel. So you can see I'm going to go through, this is my list over here on the left-hand side, of all the attributes I want to discuss and show you how to tune using BGP. So I'm going to split this video into 2 videos. We will look at tuning all of those and setting the attributes fully in the upcoming video. Now, I've got to warn you that I did do some modifications in this video to make that demo look very pretty, for it to choose the best path. I'm going to actually take everything out that I did, all of the behind-the-scenes tuning that I did to make BGP work correctly, because I want to show you what happens in a typical BGP system. If you set up BGP without having a good idea of how to work it, I want to show you what BGP does and how it just breaks. So let's sum things up here. I guess that was kind of anticlimactic because I'm like, this is going to be the best video ever. And then I didn't reach the demonstration fully. So the next video will be the true best video ever. And we'll get into the tuning attributes then. So we did see what the BGP attributes are. They're just a list of, whoa, get that out of there. They're just a list of pieces, I guess you could say, of stats to compare it to that World of Warcraft system that BGP will use to comprise its metric. The BGP metric is really that giant list boiled down as one of these will break the tie systems. So we looked at that big list, all of the BGP attributes, how it finds the best path. Now I showed you the source on there. I didn't want to put the big Cisco website URL because it's enormous and you don't want to type that in. Just go to Cisco's website if you want to see that list in detail and do a search for BGP route decision, and that will give you that whole list with a expanded explanation of each and every one of those on the decision process. Now, This one is what we half did here. I almost want to half color that bullet because we went through the basics of modifying the BGP attributes, as in you saw what the attributes were. You know what? I'm not going to color that bullet. We haven't done that. You saw the BGP attributes and what they were in a BGP table. The next video, we're going to get into tuning and tweaking those to make our router find the best path around the network. I hope this has been informative for you, and I'd like to thank you for viewing.